Hello and welcome in a new video. In this exercise, we will do some practice on the normal and tangential coordinates. So let's start. This is application 2.5. The equation of the trajectory of a ski slope is given by y equal 1 over 200 x squared minus 200. The skier with a mass of m equal 150 kilograms passes through the point A that has as coordinates 0 minus 200 meters with a speed of v equals 65 meters per second. So we have the equation of the trajectory of a ski slope. We can see that this is the equation of a parabola. So we can draw this parabola that represents the ski slope. So this is our ski slope. The skier with a mass of m equal 150 kilograms passes through the point A. So our point A is here. It has as coordinate x equals 0 and y equal minus 200 meters. So at this point A, we have a speed. The speed is equal to 65 meters per second. Okay, before starting to read the question, it's important to notice that since we have the equation of the trajectory, then we can make use of the normal and tangential coordinates or the normal and tangential acceleration, because we know the expressions of an and at. An is equal to v squared over r and at is equal to dv over dt. Let's see the question. Determine the reaction of the slope. So we need to find r, the reaction of the slope, as well as the skier's acceleration at point A. So we need to find the reaction of the slope. The reaction of the slope is a force. And to find a force, we need to apply the fundamental relation of dynamics. One of the methods to find this force is to apply the fundamental relation of dynamics or Newton's second law. So let's start, and we will use the normal and tangential coordinates. So on point A, we have only two forces. We have the weight of the skier, mg, vertical downward, and the reaction of the slope, which is vertical upward. So at this particular point, which is the minimum of the parabola, these two forces are vertical. So point A is in fact a particular point where these two forces have the same line of action but have different direction. They are both vertical. One is downward and one is upward. So let's start. The sum of the external forces equal ma. We have the forces are mg and r, the reaction of the slope, and this is equal to ma. I broke down the acceleration into two terms, an, the normal acceleration, and the tangential acceleration. Okay, we need to find r. R has only one component along the normal unit vector. So let's draw the tangential unit vector, which is a vector that is tangent to the path in this direction, directed to the right, because the skier is going to the right at A. And the normal unit vector is a vector which is perpendicular to tau, and it's directed toward the center of curvature in this way. So to know what is the magnitude of r, we have to project the fundamental relation of dynamics along the normal unit vector. So along the normal unit vector, we have mg. The vector mg has only a component along the normal unit vector. It's equal to minus mg. So the projection of mg along the normal unit vector is minus mg. And the projection of the reaction is plus r along the normal unit vector, and this is equal to man. Now if we want to find what is the projection along tau, then we don't have any force that has the direction of tau, so 0 plus 0 will give mat. This means that at is equal to 0. Let's find the reaction of the slope r. So we can write that r is equal to mg plus an, where an is equal to v squared over r, or over rho, where rho is the radius of curvature. What is the radius of curvature? We can use this formula to find the radius of curvature rho. It's equal to the absolute value of 1 plus dy over dx squared. The numerator is raised to the power of 3 over 2 over d2y over dx squared. So we have to find what is dy over dx, and we have to find as well what is d2y over dx squared. So what is dy over dx? We have to use the equation of the trajectory, which is y equal 1 over 200 x squared minus 200. We have to derive y with respect to x. It will give 1 over 200 times 2x. This means that we have 1 over 100 x, and this is dy over dx. Now, d2y over dx squared is the derivative of dy over dx with respect to x, so we have to derive x over 100. It's equal to 1 over 100. We can replace x with 0 to find rho. So at x equals 0 and y equal minus 200, dy over dx equals 0, and then rho will be equal to 1 plus this term is equal to 0 over d2y over dx squared is 1 over 100, and we can find that the radius of curvature here is equal to 100 meters. Why did we find rho? Rho is important to find the normal acceleration, because the normal acceleration is equal to v squared over rho. Okay, we have rho, we have calculated rho, we know what is g, we know the mass of the sphere, and v squared. What is v squared? Well, what is v? V is equal to 65 meters per second. So we can easily find the reaction of the slope by substituting each term with its numerical value. Okay, that remains to find the acceleration at point A. So we know that the acceleration is equal to an plus at. An is simple. It's equal to v squared over rho. It's equal to this term, in fact, 65 squared over 100, and 80, we know that 80 is equal to 0, so the acceleration is equal to the normal acceleration, which is equal to 42.2 meters per second squared.